As I go through these, I'm going to do about 10 of them. I would like you to correct yours, make changes if you need to. So I'll probably do maybe 2 in every section. So in the first section, which would be 1 through 10 on raising something to the 0 power, remember anything to the 0 power is 1. But be careful if there's a negative or a number out front. So on this one, that whole chunk is 1, but we had a negative out front. So your answer to number 4 should be -1. On number 10, the whole thing is to the 0 power. So the whole thing is 1. Next up, when we're doing negative exponents, remember negative exponents do not mean negative answers. They mean division. So what happens is we end up getting, when we have a negative exponent, the number ends up going to the denominator as a positive. So for example, with number 20. But again, be careful because this is not in parentheses. It's just the 2 that's getting raised to a -2. So that becomes 1 over 2 squared. Well, this had a negative out front. So there's my answer. And with small powers, I'd like you to, 2 times 2 is 4. So I'd like you to clean that up. Let's take a look at number 24. Again, watch those parentheses because it's this whole thing that's to the -2. So the whole thing gets sent to the basement. But if you wrote it like this, you need to go fix it. Because this was in parentheses, it needs to remain in parentheses. It matters. And the next section, 7.4, deals with, well, how do you clean up when you have a chunk of stuff like this to a power? But for now, you can go ahead and leave the answer looking like this. Just make sure you have parentheses around that denominator or it will get marked wrong. So moving on here, let's go clean up one that seems to have a lot involved, and let's take it term by term. On number 27, we have a -3, which will stay on top, and a will stay on top because it's a to the first. This means divide by b 4 times, which basically means 1 over b times 1 over b, so it puts it down on the bottom as b to the 4th. The c is really c to the first, so it stays on top. On the bottom, the 6 is really 6 to the first, so it stays on top, on the bottom where it is. And d to the -1 will go to the top as d to the first. Now also, and this is kind of how I'll know those of you who are watching the video, most people don't stop and realize that they need to clean that up. 3/6 has always been a half. So we have -1/2, really. A, C, D is what's on top. And on the bottom is a b to the 4th. And this 1 does not need to be here, but I'm going to leave it there for now. Let's go to this one, number 28, and see what happens. Term by term, let's go take it apart. A to the -1 will go down as a to the first. B to the 3rd will stay where it is. C to the -5th will go down. It means divide by C 5 times. And again, like when you divide by 2, that concept's kind of hard for some people. Notice what that means. It means you're really multiplying by 1/2. It sends that 2 to the bottom when you're doing division. And that's exactly what a negative exponent means, is division. This d to the 2nd gets to stay on the top. The 2 stays on the bottom because it's 2 to the 1st. Anything to the 0 power is 1, so that e to the 0 becomes a 1. So I'm going to cross these off as I deal with them. F to the -2 will go up as f squared. All right, and again, that concept's kind of weird for people too, but I'm going to write that out like this. Know how I told you that anything to the -1 is really 1 over it to the positive. So those are equal. And you know, if you think about this conceptually, if you were to take, just say, a piece of pizza and you were divided into halves, notice how you would have 2 pieces. Really what you end up doing is multiplying by 2 where it sends it to the top. So you can see that that negative exponent really sends it up to the top as a positive. All right, so this one's done right here, and you don't need to have these little ones on here. Actually, I prefer you take them off. So next page, go correct a couple on there. I think this is the bottom of your first page, though. We also have the property that says when you multiply, you add the exponents. Let's go take a look at number 32. Y to the 3rd times y to the 5th would be y to the 3 plus 5, which is 8. I did see a couple of you adding these up in class. That's a -2y to the 3rd times 3y to the 5th. So that's really a -2 times a 3, which should give you a -6. Okay, and let's go look at number 38. On number 38, our common base is a -2. When we multiply the same base, we add the exponent. So I end up with -2 to the 8th power, which you can go ahead and leave. Let's try one more of these. Actually, I think that's good. Let's move on to some scientific notation. Let's look at number 43. Is this in proper scientific notation? No, it's not. Because this 13.4 needs to be between 1 and 10, can't be 10. So I need to move that decimal one to the left. Really what I've done is I've divided by 10 to do that. To keep a number in balance, I need to multiply it by 10, which really means that exponent needs to go forward 1. So there's the proper answer. Let's go take a look at number 45. The parentheses in multiplication don't matter. So I would suggest that you look at this one like this. You've got 2 times 3, which has always been 6. And you've got 4 tens times 11 tens, which would make 15 tens. And that is in proper scientific notation. We've got our number between 1 and 10, not including 10, and times 10 to a power. All right, let's go do one more of these down here. And I'll pick 48. When I'm taking 9.9 times 10 to the negative 8, that negative means divide by 10 8 times. Really what that does then is it moves the decimal 8 places to the left. 1 place to get to the end, and then I'll need to move it 7 more. So I'm going to have 1, 2, 3, 4, 5, 6, 7 zeros in front of that. Now, again, if I were to scoot that decimal 8 places back to the right, 1, 2, 3, 4, 5, 6, 7, 8, you'll notice I have that number back. So that one's done. 49, there's one like this on your first test, so watch this one carefully. We've got a square. Its length is 2x to the 4th. Well, that means so is the other side, because squares have sides of equal length. How do you get the area? You do base times height, side times side, length times width, however you were taught it. It's 2x to the 4th times, you can use parentheses, another 2x to the 4th. Really what I've done is base times height, length times width, side times side. All right, when I do that, I take care of my numbers out front. 2 times 2 is 4. And then x to the 4th times x to the 4th would be x to the 8th. So those are the ones I'm going to do. I promise you that when we correct it in class tomorrow, I will pick some of these. So you should definitely get them right. Have a good night, guys.